Hello and welcome to Funnyhacks, the show where I literally walk you through hacks that are weird, unusual and the occasional useful one as well. I'm Kevin Sanderman and today I'm going to walk you through the plane.
Boy, boy, boy.
RC models are a ton of fun. I've got quite a few myself and I've introduced several of my friends to it as well. But sooner or later these models end up auditioning for the trash can. That's where this hack comes in. Today I'm going to show you how to take an RC helicopter like this and turn it into an RC plane. The advantage of an electric helicopter is they generally have one motor per rotor and therefore it's very easy to stick one on each ring and control the plane that way. Risks. Chances are you're going to be flying this in a public place, so be very aware of where the people are and make sure you don't hit them. It may sound obvious, but it's really important. Secondly, most airborne RC models use lithium polymer batteries. Lithium polymer batteries have very similar risks to lithium ion batteries, and I'll put links to this in the show notes. And yeah, don't undercharge your battery. And third, you're probably not going to be flying indoors with this, but if you are, be aware of what's around you. Helicopter 1, light bulb 0. Right, let's get into it. Now we need to work out how we want the plane to behave. Do we want it to go fast? Do we want it to go slow? Do we want to carry weights? Do we want it just to be the plane by itself? I wanted mine to fly slow and I wanted it to be able to carry weight. So I've made quite a large wingspan, which has quite a nice shape to it. Most model shops will stock pre-made wings. I preferred to make my own, and so that's what I did. It's also a lot cheaper. Now I want you to try an experiment for me. Go and get a spoon and then go to your kitchen sink and hold the spoon right beside the flow of the water. You'll notice it hangs there quite nicely. Now just move it very slightly so it just slightly skims the water. Suddenly the spoon is going to get sucked right into the water very quickly. And this tells us a lot about how a wing works. The water goes around the spoon, so by the time it actually leaves the spoon, it's going in a different direction to what it was before. So the spoon has actually changed the direction of the water, and for this to happen, the spoon has to get thrust in a direction. This is a lot how the wing works. The wing alters the flow of the air, therefore creating lift of the wing. Motor position is pretty trivial. As long as they're fairly evenly balanced from the centre of the wingspan, you're pretty good. There are a couple of factors which you may be interested to play around with though. The closer they are to the centre of the wingspan, the less impact they're going to have on the steering. The further out they are, the better they're going to have their steering. However, if there's any imbalance there, then that's also going to be more noticeable as well. You've also got to support the weight. But during flight, that shouldn't be a problem, but on the ground it may be. The other thing to consider is whether they go above the wing or below the wing. Traditionally, they've gone below the wing, and that goes in line with traditional theories. However, there's recent discussion which suggests that perhaps they should go above the wing, and you'll get greater efficiency that way. I've put mine above the wing just simply because then the propellers are less likely to hit the ground when the thing crashes. The easiest way to mount the propeller is just to directly stick it onto the shaft of the motor. We've got to be aware, however, that the helicopter will have been significantly geared, and so by directly attaching it to the motor, we are going to be spinning the thing a lot slower than the motor was originally designed to go. So therefore, we need to have a propeller which has a very fine pitch instead of a coarse pitch. And it also needs to be very short so we can get the revs up as much as possible. It took me 3 goes to choose a good propeller for this setup, so it is worthwhile having a play with it because it really does make a big difference to the performance of your aircraft. This is quite promising. However, even if the power to weight ratio wasn't an issue, the banking to the right would severely limit how long it would stay in the air anyway, so I gave myself an hour to rework the design.
How's it actually going? I see.
It is.
I thought Kevin just meant to hold it for actual filming.
Right. We got plenty of filming of it going.
Say something.
Oh,
Say
yeah.
something ominous, Kevin.
Today,
say how
pigs will fly.
no. Say how bad could it go?
Flying is easy. If you chose to make a slow flyer like I did, then a gentle throw is all it'll take to get it going. Once you've got it up in the air, giving it more power will make it go up, giving it less power will make it go down, giving power to the left wing will make it go right, giving it power to the right wing will make it go left. So you probably want to have the two motors in the inverse position. Okay, that had a lot more room for improvement than I was intending. But I learned a lot and I had lots of fun. Hopefully you did as well, because after all that's what it's all about. Anyway, keep watching the series and you'll get to see the improvements as I make them, and lots of other cool hacks of course. I'm Kevin Sandham, this is Funnyhacks. Normally when the weather forecast is wrong, that's the time for complaining, but today the weather conditions are near perfect, so I have to hurry to get the thing finished.